Okay, let's try a trickier problem. And let's try an ancient problem. This problem's over 1,000 years old. The question goes as follows. Suppose you have 9 citrons. It's a fruit. You can look it up. It's got a picture if you type it into the internet. And 7 wood apples. And when you purchase this amount, the cost is 107. But if you purchase 7 citrons and 9 wood apples, then the cost is 101. How much is 1 apple? Okay. So, let's try to go through our steps. What is it that we want to find? Well, we want to find the cost of an apple. So if A is the number of apples, the cost of an apple, that's what we want to find. And what do we know? Well, we know that, let's write down what A is, the cost of an apple. Not the number, because it's not obvious. And C will be the cost of a citron. Okay, so what do we know? We know that 9C plus 7A, the total cost is 107. And 7C plus 9A, the total cost is 101. And there are a few tricks for dealing with this sort of situation, but let's just go from what we have. We want to find A. The next thing I'd like to do is, now that we have all the information written down, is try to plug. So how could we try to plug here? Well, I could try to divide this equation by 7 or 9. If I divide this by 7, I could plug that C right into there. If I divide by 9, I could plug the A into there. But I don't want to get rid of A. I'd like to get rid of C. So what I'm going to do is I'm going to get rid of this equation. I'm going to replace it with C plus 9/7 A equals 101 over 7. So then C is going to be negative 9/7 A plus 101 over 7. And I can plug that right in here, and that gives me one equation as follows. It's a messy one, but let's see what we can do with it. Well, I immediately get this. And let's try getting rid of all the fractions, this was one of the suggestions from before. So if I want to get rid of all the fractions, what can I do? Well, I can multiply everything by 7. So I get minus 81A plus 909 plus 49A, and then we have this big one, 107 times 7. Well, 100 times 7 is 700. And 7 times 7 is 49, so that's just going to give me 749. So now, this is the equation that I want to solve. Okay. Well, is this even a linear equation? I can see right off the bat, this is going to be a linear equation. Why is that? Well, let's move everything to one side. I'm going to have a single constant, and I'm going to have some constant multiple of A. These numbers are not going to cancel out, so I don't have to worry about my variable having a constant term of 0. So that's how I know this is going to be a linear equation. So if I group the 49 and the negative 81 by taking, well, minus 1 plus 49, I can pull an A out of that. I still have this. That's going to give me, well, minus 81 plus 49. That gives me minus 32A. A plus 909 equals 749. And let's see here. This actually isn't so horrible because of the two 9s here. We could use a calculator, right? But I know that 900 minus 740, well, that would be 160. So 909 minus 749 is also going to be 160. So I could do it like that as well. And now we can see that this is a linear equation. Something of the form ax plus b, except our variable here is capital A. So constant variable plus constant equals 0. So we can just use our formula here, which would give me negative b over a for our answer. And 160 divided by 32 would just give me 5. Or we could just solve like that, and we also get 160 over 32. So either way, the cost of an apple is 5 in whatever currency we're dealing with. So not a short problem, but a very old problem that can be solved using just linear equations.